Здравствуйте. Меня зовут Локшин. Я работаю с базами данных чуть более 19 лет. Имею опыт работы с PostgreSQL, MySQL и Microsoft SQL сервер. В данный момент я работаю в Mail.ru Group. Участвую в разработке игровых серверов, специализируюсь на оптимизации взаимодействия игровых серверов с базами данных. В настоящее время наша команда для работы использует СУБД PostgreSQL. Другие команды, которые работают над играми в Mail.ru, насколько я знаю, используют либо MySQL, либо PostgreSQL, либо ряд NoSQL решений. За время моей работы в Mail.ru наша команда мигрировала 2 игровых проекта с MySQL на PostgreSQL. И в этом докладе я хочу поделиться причинами, почему мы мигрировали на PostgreSQL. Также рассказать, какие сложности у нас возникли в процессе перехода эксплуатации и как мы их решили. На следующем слайде представлены краткие характеристики проектов, в которые мы мигрировали. Первый проект использует несколько серверов игровых. Соответственно, игрок может зайти на один из серверов и зарегистрироваться там и играть. Взаимодействие между игровыми серверами минимально. Каждый игровой сервер обслуживается своей базой данных. На проекте 2 существует один сервер и, соответственно, к нему одна СУБД на одной машине, и все запросы идут к ней. В связи с архитектурными особенностями для проекта 1 нам требуется минимальное время отклика на запрос для того, чтобы обеспечить одновременную работу тысячами пользователей. И в связи с этим нам крайне желательно на этом проекте, чтобы вся база помещалась в оперативную память. Изначально в первом проекте использовалось 2 базы данных СУБД. PostgreSQL для ведения аналитики, логирования запросов и авторизации, и MySQL для собственной игровой базы и для биллинга. Нам хотелось уменьшить вариативность структуры.
We wanted to decrease the structure. We didn't want to make any errors that you can have when you have 2 databases, or we even want to avoid all the errors that you have in one database. We didn't want to write a code that would work for 2 databases, but rather write a code that works for one database and use it. If you consider paid solutions like Microsoft Excel Service or Oracle or DB2, then we were not satisfied with the free versions in terms of productivity, and the paid versions were only good enough when we had to license the core. But even if you look at the standard edition, it will amount to dozens of millions. The enterprise version is the best version, and it will exceed 100 million if you consider our number of cores. We could also look at no-skill solutions, but when we were deciding to transfer to Postgres, they were not so popular as they are now. And the main reason, the second reason, was that it is already for the relational database, and you will not be able to. And if you had to change the NoSQL, you had to change the entire project quite seriously. So, as a result, we were left with 2 options: Postgres or MySQL. Which one to choose? We estimated all the options. We looked at the fact that we already had the game database analytics, and there were thousands of queries, quite difficult, with tons of joins, subqueries, and if you need to rewrite it to MySQL, that will be quite a big problem. Clearly, you can do it if you start but it will cost you too much human resource, too much human man hours. So, if you look at the reverse, the queries that were processed by MySQL billing and the game database would easily fit into Postgres without any major editing. So, if Postgres was good enough in terms of productivity, then we would rather do all the transition to Postgres. So what concerns did people raise before we transferred to Postgres? One is that there's no decoding in the write-ahead log to be able to export queries from there. And in MySQL, there's a utility that that you can use to export queries from the binary logs. It does not exist in Postgres, but over the 5.5 years of work, I didn't have an opportunity where I needed it, because all our data is logged in quite a big detail on a special server, and you can restore the entire picture using this particular server. Another problem was the vacuum in the background. The concern was that if you compare it against vacuum, against MySQL, vacuum will either lag behind, will not be able to collect data, and the database is going to grow and grow. Or it will be able to do everything on time, but we will not be able to give the queries that MySQL used to process. And the third concern was the elementary operation speed, because most operations are quite simple on the game server. So people raised concern that MySQL was quite simple, but they were quite optimized on that service. So Postgres, with its architecture, will simply not be able to catch up with it. Indeed, there were problems at Postgres with the vacuum and other productivity issues 10 years ago, maybe more than that. But quite a number of optimizations were introduced quite a long time ago that were able to cover these issues totally. And while with the argument number one, you could raise arguments against it, you could discuss it. Concerns number 2 and 3, well, here you simply had to show how that would work. We launched test servers a number of times with real users, and we profiled loads on the server as well, using our bots, our game bots. And tests demonstrated that Postgres was quite reliable, and then we finally transferred to Postgres. Now, if you look at the history of Postgres development, then you can see that Postgres has been issuing new versions every year, whereas MySQL issues new versions every 3 years. And I wouldn't even say that 9.0 at Postgres is anywhere near MySQL, whereas the functionality added is more or less the same. So if you look at it from the general point of view, then why does Oracle need to develop MySQL when they have similar paid versions? So basically what they're doing, they've been raising a free competitor for them, right? But if we look at the existing functionality of MySQL, we can see there's quite a lot of features which didn't make us quite happy. The outer table at MySQL, for instance, it's quite slow. In certain cases, in most cases, it leads to the re-establishment of a table. If we add the nullable column, then MySQL has to rebuild it, to recreate it anew. So if there's a big number of data in that column, it will take quite a long time. All Postgres needs to do is to update the meta information. The reason for this is in the physical view on the disk. I'm going to discuss it a bit later. The next interesting thing about it is how identity is organized in the InnoDB engine. We used InnoDB engine because it's a transactional engine. So we wanted to work with the database in the transactional regime, so we used it. So identity is the sequence of unique identifiers which the database provides. Identity at MySQL is auto-increment. Oh, okay, so far so good. But then it turned out that the auto-increment values can, in some cases, repeat. So why is that? Why so? Because it should be unique, shouldn't it? But in some cases, at MySQL, numbers can repeat. And this is documented. So they believe it's not a bug, but rather a feature. Although, in my opinion, it's quite a serious bug. Now, let's look at what the help file has to say. Even if you have read it before you start using MySQL, then there's a great probability that you could have missed this particular phrase. Does any of you see anything special in these phrases? Something which can break the uniqueness of your auto-increment? I'm sorry, I cannot hear what the people from the audience are saying. Anybody? Right. The counter. The change counter is stored only in main memory. So when you start your work, it collects the hash identifier from the table and then simply inserts it. It never stores anything anywhere. Well, with the exception, clearly, of the cases when you store the data from the table, which means that when you insert a line, then you delete it and you unplug and plug in the MySQL, you will see double identifiers. It'll give you the identifier which it already issued to it. As a result, we had loading doubles. We had identifiers that were doubled. So you should always read the documents for MySQL very closely, because these authors, the authors of MySQL, have their own view at what the standard SQL is. For instance, what should these two queries do according to the SQL standards? The first one should clearly create a table with a certain limitation, and the second should crash with an error, because we have a value which has a limit, which imposes a limit, which does not meet the limit.
And in MySQL, that is not like that, and it is also documented somewhere at the bottom where select clause syntax is described. It is called that the check clause is parsed but ignored by all storage engines that are in MySQL. So it will return no notification or alert on an error, nothing. We just set -1. And what needs to execute the limitation? is to develop the trigger yourself, and that is also a quote from the manual. What does the query, the bottom query, have to return on SQL standard? So what values will there be? So it should return the value 2, 1, but in MySQL interpretation the return will be 2, 2, because it computes the statement from the left to the right side, and the result for the next attribution is seen. And this behavior is also documented. Next problem that we did not like in MySQL is that in MySQL you can not run any DDL clauses in transaction. Why is that needed? Well, if everything runs smoothly, no transactions are needed for DDL. But if something goes wrong, we would like to go back to at least what you had at the beginning. If you write a large migration script and it crashes in the middle, then either you have to write it in such a way that it should understand that part of the transactions have passed and another part not, or you should do it manually if it crashes. Well, it rarely happens in production, but in test servers that is a real picture. And you can say, let us break the script down into many small bits and launch one by one these atomic actions. But it will not work in MySQL either, because bearing in mind its particular features, it will have to change the information in metadata catalog, in storage engine, and also in binlog. So in MySQL 8.0, they promise to have transaction at the level of statement. So it has not been released yet, but when it is, we would be able to do alter table pretty safely, at least of one of the tables. Another thing that I would like to touch upon is replication in MySQL. Oleg Tsarov at PGConf 2015 had a very good presentation on this topic, and on the website of the conference there is even a video with his presentation, so if you are interested in it you can have a look at it. But let me just point out the current problem. So we are using asynchronous replication, and in MySQL there is statement-based and row-based replication. And if we refer to MySQL manuals, the last insert is something that we're interested in. Statement-based replication can easily be broken by ordinary insert. So if in this insert we order the selection not in one single understanding, we will receive the incorrect replica, and we will not learn that at the moment of insert. We will learn it only when we start using this replication or when other statements crash. In row-based replication, this problem is not present, but there are other problems. As in MySQL, several storage engines can be used. There has to be a separate replication log run that is run at the logical, not physical level, and it is separated from storage engine rights, and it has to be run transactionally. Therefore, it implies additional costs on replication, and logical changes from replication log have to be relayed the slaves using additional resources. And up to 5.6 MySQL, if master had a very large activity, the slave has to be faster in terms of performance than the master. Other things that I would like to focus on are not that obvious all the time, and it would be really interesting to pay attention to them in migration. So, non-vivid indexes, foreign key. MySQL creates them. In Postgres, they are not created. So if you have some ready-made schema and you believe that all indexes are present there, you just get it to Postgres, you test it, and it is all okay. But as MySQL creates non-vivid indexes on foreign key, it might run with large data, not that fast as you would like it to do. Another thing is work with JSON. So we stored JSON in varchar type field up to MySQL 5.6. There had been no other alternatives, and in MySQL 5.6 there turned up a number of stored procedures. We did not use it at production because of the speed of its processing. In MySQL 5.7 support of JSON was embedded, and in Postgres it was introduced much earlier in 9.3. So we opt for using JSON, and at 9.4 there appeared JSON B. We had a look at it. B, binary, means that it should take less than textual view of data. We measured it and got very interesting results. Adding one number into the array gives plus 12 byte to the size of JSONB, and every increase of the digit that is a factor of 4 gives plus 2 byte as well. And what does select give to it? You can try to guess. A little bit less. A bit less than 100. So it returns 88 bytes. That is for active participation and guessing. Well, generally speaking, it's not a problem, but for us, the size is really critical, because we need to make use of memory effectively, and as JSON was not processed at the server, with exception of cases like counting statistics once in 6 months, but you can use it You can do it using simple og select. So we opted for JSON, as JSONB did not give anything much better than JSON, and it enables you to work faster with JSON if you need to analyze something inside, and gives better capabilities of indexing. There is another issue that I believe is pretty serious in Postgres, that is absence of cluster index. I believe it entails at least three problems. First of all, the general increase of the database size by the size of the index, and for our first project, that is a pretty grave problem. Another thing is absence, the optimizer side, the chance to run fast merge joint without additional lookups in the side page. If you have a covering index, then you can do so, but covering index without cluster index will also run thanks to the data size. And another problem is random reads. For ordinary disks, it is a serious problem. For SSDs, it's not that grave, but anyway, you will have more reads and unnecessary information that by chance was in the same blocks that we needed. The third problem can be tackled thanks to cluster command that can rectify the situation, but the first and second problems will not be eliminated because clusterization is not supported in Progress when tables are changed, and it also has certain blockings. To avoid them, you can use PG repack extension or analogous to it that enable to do that in the background. It's only natural that it's better not to do it at peak load hours, because it gives additional load to the subsystem. And so if this cluster index is such good a thing and it is present in MySQL, the question turns up: when will it turn up in Postgres? And if we have a look at newsletters on Progress, we will find an answer to this question, that for this implementation we need to redevelop a lot of codes, and so far it is not clear how, and in the near future it will not turn up. And the answer is 10 years old already. Alexander Korotkov, in his presentation on storage engines, promised to speak about this as well. At least I saw it. Another issue, not that grave, is absence of unsigned values in Postgres. MySQL has it, Postgres doesn't. And as we write servers on Java, we do not have unsigned types either. Maybe that is why we do not like MySQL and we do like Postgres. Well, this can be tackled in the following way. Either you do not need this excessive 1 bit, or you can have big int field, and we do not like doing that because we like saving our memory. Or you can present signed as unsigned and convert them. Yes, and there is an extension, but in the standard batch it is not present. Another particularity is that Postgres, working with Java, the standard GDBC driver does not have support to Unix domain sockets, and MySQL has it. But in the network, there are several patches that add these functions, and we came up with our own patch on their basis, and we measured it and received plus 10-15% of performance growth at our loads. But our loads are pretty specific, so we decided to test it, and we launched tests to drivers, and tests crashed. We started looking into this matter, and they crashed at a statement cancel call that cancelled the query and hung up inside the driver, inside GMI. Not to look further into this matter, working with the unit domain soccer, we substituted a special command to server to PGConf, and it has another problem, because if we have a limit of the number of connections, we would not be able to come up with a new connection, but our application is limited by its connection pool, and no one connects to the server, and the limitation on the server side is a bit higher. And just for my information, I had a look at how MySQL cancels statement at GDBC drivers, and it is done in an analogous way. While I was getting ready for this presentation, I noticed that starting with 12.08 driver release, there is an opportunity to add your own socket factory, using which you can transfer circuits that the connection will work with. For example, you can transfer a Unix domain socket there as well. That would be made on the basis of one of the patches that are present in the network. But as far as I understand, the problem of statement cancel has to stay there anyway. Another aspect that it is worth paying attention to is that by default, case-insensitive search is present in MySQL, and in Postgres it is case-sensitive, and up to 9.3 it can be tackled with the help of functional index and lower or uppercase. And starting with Postgres 9.3, there is a very useful extension for us that is CI text, and it eliminates all the problems with case-insensitive search. Another useful feature that we used in Postgres are partial indexes and null fields. And partial indexes naturally are not an exclusive thing, but this function is not present in MySQL. And together with the data view, it enabled us to save 5–10%, bearing in mind that MySQL has cluster index, and in Postgres, in some cases, we had to come up with additional index. So as for partial indexes, everything is pretty easy. We do not write these values, and the index becomes smaller.
So what happens with the views of the lines? How do you show lines in MySQL? In the beginning of each line, there's a certain shift against the beginning of the line. The first three are always technical fields, and then it all moves to our data. This data takes 1 byte each, in each case. If the field is null, then there'll be a shift, as in the previous field. But the elder bit will be 1. And if the entire line is more than 128 bytes, then you will have 2 bytes for each field as a shift. So what do we have at Postgres? So there's this table we have created. What will PG column size return to us? It returns data based on meta information. Smaller 2 bytes, bigger into 8 bytes. Cannot be any higher than 10. Your proposals? $40. 40 is only half the right answer. It can be 40, but it can also be slightly less than that. So here's to you for your correct answer. Yeah, this is totally correct answer. Well, I don't know who to give the prize to. Nobody else wanted to try and answer. Indeed, it's at the 40. If we're on the 64-bit platform, or it's 36 if it's on the 32-bit. Actually, if you do the other way around, you get 34 bytes. Let's change the places. So what does happen there? We can add the page inspect extension there, and then we will see that indeed in the first case we have lost 6 bytes to the leveling of the 64-bit case. In the second case, there's no leveling. In the first case, had we added a number of small ints, they would be put in the place where the leveling is gone. Well, I, for one, fail to understand why you need this leveling. Well, I clearly understand it, but the profit which you get from it and what you have to pay is that the leveling takes slightly more cash and reduces our options. So, at least this is something which is open for discussion, isn't it? But if you know these features of Postgres, you can place the columns in such a way that the leveling takes the least possible space or does not exist at all. But there's one point to it. When you create a table, you can select the order. But when you add, then there'll be no particular order, no particular sequence, because they'll be added in no order. You cannot tell business in what order to add their fields, right? As a result, you can get gaps in the leveling. So, with the same reasoning, the columns have the columns with variable length should be put at the end of your convoys. So, warming up the database. We use the PG pre-warm. it helps to upload tables and indices into the RAM. If everything fits in, then we upload everything. If it fails, then we pre-warm just the indexes. This helps us to prevent users from seeing a number of lags. Because if your load is high, if too many users come running to you at the same time, then after PG pre-warm, the users will not see that you have to warm up your database. PG Hibernator is another good extension. It helps you to share the content on the disk and to read it from the disk at the start. But it is only there for 9.3 and N4. Now, how did we do the migration for the project? The time we given for the migration was 4 hours in the first case. The database structure coincided, so we migrated our shards in a sequence. There was no business logic for the data, but since the migration was extended over time, we couldn't write just one code that would be able to migrate everything. So we had to prepare a special app on Java. So we used Copy Manager. It's the wrapper for the GDBC. We also use the standards optimization. We unplugged for R&D. We create the index. So the actual time of migration was under 1 hour. We also wrote a utility for reverse migration in case something would go wrong. But we did not use it because everything went off well. In project number 2, the time for migration was 2 hours, but the database was different. As this was one server, we migrated everything in one go. There was no business logic there. So what we did, we exported from MySQL to CSV, then PGSQL, and copy from PSV. But then we found out that we did need the business logic, and we couldn't fit into 2 hours. So we had to do it in a parallel way. We exported part of data so that users would see it as a single database, but inside we did the so-called lazy migration. Whenever the new user would would access the server. So, as a result, the time of migration was quite small too, and we did not need to write the utility for reverse migration because we were already quite sure that Postgres would not let us down. Now, some of the issues we had to face in course of the operation. Actually, there weren't so many issues because we'd test everything quite accurately, and the Postgres never let us down before. Now, in one case, we saw that after update of the big table, the table had to swell. As a result, it swelled quite strong. Until we did vacuum. So, what we did, we made a mistake because we did not expect that this would happen. So we had options. Either you convert your users one by one, or you use it in batches, or you just need to know that you need to apply vacuum. Now, problems with vacuum. A brief summing up. At the moment, present Postgres versions have no major problems with vacuum. Usually, after vacuum, we have around 10 to 20% of the space which is not used. When you do maintenance, you either plug in vacuum full or you do PPG repack in certain cases. But if you do something wrong, then you can see that your table will swell a lot. Now, my conclusion. Based on our metrics, after we transferred to Postgres, we accelerated the time 10 to 20%. We reduced the time for maintenance because we could alter our tables quicker. We somewhat with data center in terms of the database volume, and we increased the overall productivity. Now, a very quick Q&A. Good morning. Thank you very much for this report. Now, question. The number of servers, is your Postgres on physical service? Yes, on physical service. How much hardware do you use? Did you use the same number of servers as opposed to MySQL? Yes, we used the same number of servers. With Project 1, there was the app server. It was on the same server where the database was. What we need, that the requests are executed very quickly, so we cannot distribute them to other servers. So it was one-to-one. In the second case, it was on the same piece of hardware, where MySQL was. Another brief question. The architecture of the app, did you have to change? Did you to adjust it to sharding? No, we did not change the architecture. Good morning, Fyodor Sigai. What system did you transfer? What was the load? Because I used to work at Miller some time ago. We had several tens of thousands of users online at the same time. Yeah, and it's the game. It was the games. I'm from the games department. Another question. Good morning. Thank you for your report. Brief question about the PG repack. When PG repack works, it creates quite a big load on the subsystem. Additionally, there are mutual blocks. As a result, system does the cancel backup. Is there something which disturbs the system? So the question is, when do you use your PG repack? In what time of the day? Yes, it does create additional load. But like I said, you need to launch it clearly at the time of the lowest load. What if it does not have enough time to do its bit? If the tables are too big and it takes some time to create the indexes? Well, I can say that we have enough. We have enough time.